Here, I just took a screenshot from the internet to kind of give you guys a visual of what these different stages can look like. So I want you to remember that the cyst stage is the infective stage, and it's also the stage it's reproducing. So when we look at Entamoeba coli, you see we've got one nucleus here, and the outer ring of that nucleus is pretty thick, and the karyosome on the inside here is rather thick. It's bigger. It almost looks like an eyeball. Trying to remove that annotation. And then we look at Entamoeba hartmanni, and you see that the nuclei is a little bit larger than it is for the Entamoeba coli. And then Entamoeba histolytica, there's little chromatin bars that you are karyosomes that you could see around the nucleus, around the outer edge. So it's important that you guys are able to recognize the differences in the nuclei. And then if we go and look at the cyst stage, you'll notice that there's multiple nuclei present inside the cyst stage. And then there's also little vacuoles in some of these organisms. We look at Entamoeba coli, you see one, two, three different nuclei. And then we look at Entamoeba hartmanni, and you see one, two nucleoli. It almost looks like a smiley face there. Some of the other species that we mentioned or failed to mention was Naegleria fowleri, and I'm gonna just take a quick peek at the next slide and see if that's mentioned. No, it's not. So let's go back and cover that a little bit more. So one of the non pathogenic species we mentioned was Blastocystis hominis, and you could see a picture of that at the bottom there. And then we have an Iodamoeba bushii organism. So these are considered non-pathogenic, but they can be found in the intestinal tract. So it's important for you guys to be able to recognize these parasites. So one thing I want to note about the Iodamoeba species is you see that large vacuole present inside of this stage. That's characteristic of Iodamoeba bushii. And then Naegleria fowleri, this organism causes meningoencephalitis, so it is considered pathogenic. What essentially happens with Naegleria fowleri is that um, it happens in the summer months. So if somebody takes their children swimming in small ponds or small lakes, that it's inhabited by this parasite. So whenever somebody essentially dunks their head or goes underneath the water, that parasite can enter through the nasal cavity um, and cause an infection of the brain. So Naegleria fowleri causes an infection of the brain. It's called like a brain-eating parasite, essentially. So we could diagnose Naegleria fowleri with an autopsy of a patient who's passed away, or we could look for it in cerebral spinal fluid. So a lot of the times, whenever you guys hear of a spinal tap, one of the things they may be looking for is a parasitic infection. So it's important for you guys to be able to note that you could see a Naegleria fowleri species. So we have three different forms here that I want you guys to take a look at, and you see the flagella at the end of this form here. So Acanthamoeba species, that's another organism that can cause an infection. It's not non-pathogenic, so it causes granulomatous amoebic encephalitis. So I want you guys to review your book. This organism is discussed on page 75. So there's at least 6 different species of the Acanthamoeba species. They cause chronic granulomatous lesions in the brain tissue and may contain CHOPs and cyst stages. They've also been isolated in upper respiratory tract. So I want you guys to take a good look at that on page 75 and 76 to read up on this Acanthamoeba. I also wanted to note that you guys can look at all of these different diagnostic characteristics of these organisms on table 5-2 on page 78, 79, and 80 and 81, and this is where you're also going to get your visuals for you guys to be drawing out these organisms when you're talking about them. So when you guys do your outlines, you could talk about Entamoeba histolytica, you could draw the cyst stage and the troph stage, and then just take a good look because it really gives you good information on this page. So like the Entamoeba coli organism can have up to 8 nuclei, and the Limax nana, you could see the cyst stage, and that's what's present on this slide here. There's a cyst stage in there, and it could have up to anywhere from 1 to 4 um, nuclei present in the cyst. So if we look at the one on the bottom left, there's 4 nuclei present in that one. You have to look really closely to see it. Again, I want you to look at Iotamoeba boostii, and that's found on page 79. You could note that the cyst stage has one nuclei, often with a large glycogen vacuole, and that vacuole is going to stain brown with iodine. So just please take some time to review these pages and get a good look at the description of these organisms so that you are able to recognize them and eventually someday help diagnose infections. I want you guys to keep in mind as I'm going through these lectures that these lectures are only like a supplemental part of your education for each week. So each week you should not only be listening to the lectures, but you should be reading the book, outlining the book, drawing these different stages, answering the review questions, answering the case studies, answering the questions at the beginning of the book, answering your objectives at the beginning of the chapters. If you want to be successful in this course, you need to take all of these different methods of instruction and spend the time working on them to um, get a good grasp of the course, because you're not going to learn every single thing about parasitology, virology, and mycology just from a lecture. And the reason I mentioned that on this slide is because we're moving through the protozoa chapter pretty quickly. We're already on the Mastigophoria class, but I really want you to take some time to look through the organisms that we previously covered, because these next few organisms that we're going to be discussing get a little bit more in depth and a little bit more they're seen a lot more common, especially in the United States. So the next class we're going to talk about is Mastigophoria. These organisms that we want to consider in this class are going to be Giardia lamblia, Dientamoeba fragilis, Chilomastix mesnili, Pentatrichomonas hominis, and then Trichomonas hominis. So flagellates in the class Mastigophoria include the pathogenic protozoa that inhabit the gastrointestinal tract, atria, bloodstream, and in our tissues. The two common non-pathogenic species that we're gonna discuss are Chilomastix menzenili and Pentatrichomonas hominis. These organisms are going to need to be differentiated from the infectious or pathogenic organisms like Trichomonas vaginalis and so on and so forth. Giardia lamblia. This is the most common intestinal protozoa in the United States, and it's the most common of the intestinal flagellates. Where you hear often about Giardia lamblia infections, especially in Minnesota, where they've got the land of 10,000 lakes, because essentially what happens and how people get infected is they will ingest the troph stage from ingesting water from like one of the lakes that is infected, and that's one of the reasons that it's mentioned that people should boil their water before drinking or filter their water rather than drinking directly out of the lake, because you could get a Giardia infection. So Giardia lamblia. So the method of diagnosis for this parasite, we're going to want to recover and identify the troph or cyst stage in feces or in the duodenal contents. So specimen requirements: at least 3 stool specimens should be examined for possible parasites. The trophs adhere to the duodenal intestine mucosa via a sucking disc, so they're not going to be shedded out in the feces as often. So that's why we're going to want to take 3 different stool specimens to make sure that we have to confirm that we have an infection or to rule out an infection. So a permanently stained smear for each specimen should be prepared and examined. We're going to want to examine areas of the mucus in feces for possible presence of parasites. And then there's also a string test. We could also do antigen-based immunoassays on fecal samples to see if we have a current infection. So fecal immunoassays provide a more sensitive detection of the parasite. Most often, though, doctors are just going to want to collect stool samples because stool samples is where we could actually see an infection of the organism. So Giardia lamblia is also can be called like by their disease names of Giardiasis, or more often you're going to hear about it being called traveler's diarrhea. So symptoms of this organism are going to include abdominal pain, foul-smelling diarrhea, foul-smelling gas. It's known as purple burps and it smells like rotten eggs. It could cause a mechanical irritation of the intestinal mucosa with shortening of villi and inflammation of the fauci. Malabsorp, malabsorption, malabsorption syndrome may occur in heavy infections. So some people may demonstrate an IgA deficiency, or people with an IgA deficiency are going to be more susceptible to this parasitic infection. The stool does not contain red or white blood cells in a Giardia infection. One thing to mention, while Giardia is distributed worldwide, there have been some outbreaks that are related to cross-contamination of water and sewer systems. Travelers in areas such as St. Petersburg, Russia, and some areas of the United States may experience infections with Giardia. So I want to just take a quick look at the organism here, the troph and the cyst stage. So the troph stage is generally the one that's a little bit more easy to diagnose. Sorry, I have to cough again, so hold on. So the troph stage of Giardia lamblia is often referred to as looking like an old man with a cane, but personally, I don't really see it. I never did see it, but if you guys happen to see an old man in the cyst stage, more power to you. One thing to note is that in the troph stage, we're gonna see median bodies. So you see this median parabasal body here inside of the organism. We're gonna see flagella. So you see these flagella here. We're also going to see axonemes, so that's just like essentially like the spine down the center. We're going to see a dual nuclei with the troph stage, and then sometimes you could see a sucking disc on this organism, and that's what you see here at the end. So I just want you to point out these diagnostic stages. So this is the troph stage. Now the cyst stage, you could see here, it doesn't really have the flagella anymore, and oftentimes there's going to be up to 4 nuclei present in the cyst stage. Again, that's because it's going to be dividing into a new organism. But most of the time, you could just look at Giardia, rather if it's a troph, no matter if it's a troph or a cyst, and know it's Giardia because it looks pretty unique, I should say. So, just this is a Giardia lamblia troph and cyst stage. So the next organism we're going to talk about is Dientamoeba fragilis. So for Dientamoeba fragilis, we're going to want to identify the trophozoites in feces. There's no known cyst stage with Dientamoeba fragilis. So again, we're going to want to take at least 3 stool specimens should be examined for parasites. We're going to want to stain each spear with a permanent stain, and we're going to look for trophozoites found in the stools. Major pathology diseases are usually asymptomatic but may be associated with diarrhea, anorexia, and abdominal pain. Distribution is worldwide. Um, There's a fairly high association between Enterobius vermicularis and Dientamoeba fragilis infections. There's no cyst stage again. I mentioned that again. Most organisms, so generally 60 to 80% have two nuclei, and only 20 to 40% will have one nuclei present. So let's go to the next slide. I think I have a picture to help with this organism. Yeah, so Dientamoeba fragilis. Some people note that it was given that di part of its name because it's characteristic for this parasite to have two nuclei. You're going to see that we have a food vacuole present inside of the organism, and it's roughly 5 to 12 micrometers. So this organism is rather small. So it's going to take a keen eye to find this parasite or this infection in stool. Okay, so now Trichomonas vaginalis is another parasite that you're going to hear a lot about, especially um, if you're working near a reservation, because Trichomonas vaginalis is essentially a STD. So you're gonna see trick, at least once a month when you're working in the lab, especially if it's a lab that serves the clinic, where you're gonna get a lot of wet preps from women and urine specimens. So it's really important that you're able to identify Trichomonas vaginalis. The last time that I taught this parasitology course, I had two students that came back after their clinical rotations, and they're like, we saw trick." So I really want you guys to get a good understanding of what this parasitic infection includes. So I don't know if I've mentioned this before, but all of these presentations are available for you to download um, the um, the slides on in your files on Canvas. So if you download these files and follow this Bing link here, it'll actually show you a GIF of Trick, and I really highly recommend that you Google it and take a good look at these GIFs to see how motile these organisms are, because I don't want you to be looking at a urine sample at clinical, see something swimming around in there, and not know what it is, because 9 times out of 10 it's going to be a Trichomonas species or a Trick infection. So disease names is trichonomad vaginalis, urethritis, or just simply trick. Major pathology and symptoms. In women, we're going to see persistent vaginal inflammation, yellowish froth, foul-smelling vaginal discharge. So sometimes whenever you hear of a woman having a smell, it's because they have a trichomonas infection. Patients are going to experience burning with urination, itching and irritation of the vaginal area. So if somebody has itching down there along with a kind of a fishy smell, it's more than likely going to be a trichomonas infection. Men are usually asymptomatic, so they're not going to experience any symptoms with a trick infection, but that it's an STD, so most of the time an infection is going to come from a man. Distribution is worldwide. We have two different types of organisms that fit into the trick species. We have Trichomonas hominis, and this one's found as a fecal contaminant in urine samples. But we're all when we're looking for Trichomonas vaginalis, Trichomonas hominis may be uh, noticed. So it's really important that we take the time to identify these organisms. And the book also mentions that we want to take a um, special care when examining specimens from children, because it could be indicative of child abuse. So here's a picture of the Trichomonas species. You're going to note that we have a central nucleus here. We have this axostyle. We have a posterior axostyle. We're going to have the 4 anterior flagellates. And some of them have this undulating membrane on half the body, so you could see that a little bit more prevalently on this organism, on this one here. And then we have costa. So you're not going to get an image that looks as beautiful as this one whenever you're looking at trick. Most of the time, you're just going to see a single-celled organism with flagella that are motile, and it's essentially just swimming around in urine samples. So we have some non-pathogenic intestinal flagellates, and I just included some pictures here of these organisms so that you know what they are. We have Chilomastix menzenili, and that's the troph stage that you see at the top of the slide, and then we have Trichomonas hominis at the bottom end of the slide. I want you to note that on the Chilomastix menzenili, we have a curved posterior tail essentially, and then we have a rather longer tail on the Trichomonas hominis. So if we go back and look at the Trichomonas vaginalis, you'll note that the tail is a lot longer in the Trichomonas hominis. So I just want you guys to take some care in looking at these non-infectious or non-pathogenic flagellates, and you could also find them on page 88, and please make sure you draw them. Okay, the next order we're going to cover is kinetoplasts. So in this order, we have pathogenic Trypanosoma species and Leishmania species. These are flagellates, and they're found multiplying in the blood, so they're known as hemoflagellates. They're also found in the tissues. All these species require an arthropod as an intermediate host, so you cannot get an infection with these without some kind of an arthropod vector transporting these hosts into the humans. They exhibit varying morphology in specific locations in both humans and the arthropods. So in the genus Trypanosoma, we have two subspecies that we worry about: Trypanosoma brucei rhodesiense and Trypanobrucei gambiense. These cause East and West African sleeping sickness, respectively. The disease are transmitted by the tsetse fly as the intermediate host. I want you to remember that Trypanosoma is transported by the tsetse fly. So we have different types of the phases in these organisms. We have a tropomastigote form and an amastigote form for the Trypanosoma species, and I'll get into more details whenever we cover the Trypanosoma specifically. But we also have a species of Trypanosoma known as Trypanosoma cruzi, and these species are found primarily in Central and South America, and more recently they're being noticed in the southwestern United States and Mexico. So California and Texas are seeing more Trypanosoma infections. The Trypanosoma cruzi is spread by the Triatoma species bug, also known as the kissing bug, reduvid bug, cone nose bug, or the vinchuca bug in South America. So it's important for you guys to know these different types of vectors that are transporting these diseases. So I think before I get into too much detail on these, I'm going to go to the next slide and talk about them specifically. So here again, here are the different species that we're going to talk about in this order. So the method of diagnosis for Trypanosoma brucei rhodesiense or Trypanosoma gambiense is we're going to examine fluid from a bite site, chancre, or a buffy coat of the blood. And we're going to look for the trypomastigotes during the febrile period. So we're going to look for these organisms in a thick blood smear. So generally, whenever we make a smear for hematology, we're going to do a thin prep. But whenever we're looking for parasites, we're going to want to do a thick prep. And that thick prep kind of gives us a better chance of diagnosing these diseases. Both of these smears are going to be stained with Giemsa or Wright stain, and later in the infection, we could find these organisms in lymph nodes or even cerebrospinal fluid. For cerebral spinal fluid, we're going to want to concentrate the cerebral spinal fluid to recover the parasites. And again, whenever we mention the Buffy coat for blood, essentially what we're going to do is we're going to collect a blood sample and put it in a microhematocrit tube. We're going to spin it down, and whenever you spin it down, you get this little coat of clear cells, and that's considered the Buffy coat. And I wish we had an opportunity to display this in our laboratory, but we don't have the right centrifuge to spin these down. I'll look into it. So the diagnostic stage is the tropomastigote form, and we're going to look for that in that Buffy coat in the plasma. Major pathology and symptoms. So there's going to be a lesion at the bite site, also known as a chancre, usually seen in non-Africans. We could see enlarged lymph nodes, especially in the posterior cervical chain. It's known as Winterbottom sign. Fever, headache, night sweats, joint and muscle pain, central nervous system impairment in 6 months or 1 year, infection with Trypanosoma brucei gambiense, and within 1 month of a rhodiense infection. We could patients can experience lethargy and motor changes, and some patients are going to go into a coma or death. And death is from cardiac failure from Trypanosoma brucei rhodiense. It's important for you guys to note that these are African sleeping sickness, because that's what you're going to hear mostly whenever you're talking about a Trypanosoma infection. Red blood cell agglutination is commonly observed in vitro. There's going to be high levels of both IgM and spinal fluid proteins are characteristic. IgM antibodies in spinal fluid is diagnostic for this organism, and we could also do an ELISA test, enzyme-linked immunosorbent assay, to detect the antigens in the serum. So let's go to the next slide and have a look at this organism. So this is what we would call the tropomastigote stage. Some people say that it looks like a seahorse, but I want you guys to note that we have this anterior flagellum on the parasite here. We're going to see an undulating membrane, so that little membranous sheath-looking thing on the outer edge is the undulating membrane. You could also sometimes see a nucleus inside the parasite. I'm trying to draw an arrow there to that nucleus. And that's Trypanosoma tropomastigote form. So this could either be Trypanosoma brucei rhodiense or Trypanosoma brucei gambiense. Again, it's depending on where the infection occurred. You also should remember again that this is going to be transmitted by the tsetse fly. So tropomastigotes are ingested by the tsetse fly upon taking a blood meal. They're going to multiply in the fly's gut, and then that organism is going to be moved to the salivary gland. So then whenever the tsetse fly bites a human, that tropomastigote from the salivary gland is going to be deposited into the patient whenever they take another blood meal. And then that tropomastigote is going to multiply in our peripheral blood and cause a disease. And then later on, it's going to affect the lymph nodes and central nervous system. It's called the African sleeping sickness because most of the time, when it's diagnosed, the patient's already either going into a coma or having cardiac failure and potentially death. So the next disease parasite we're going to talk about is Trypanosoma cruzi, and this is also referred to as Chagas disease. So the method of diagnosis, we're going to find a mastigotes in stained tissue scraping of skin lesion, the Chagoma, at the bite site. We're going to want to identify the C-shaped tropomastigotes in a blood smear during an acute exaggeration of the symptoms. Excuse me. So whenever a patient's experiencing a spike in their fever and other symptoms that are being exacerbated, that's whenever we're going to want to take a blood sample and make a smear. And again, we're going to want to make a thick smear slide for this organism. We could also do a xenodiagnosis by allowing uninfected bugs to feed on a patient and then examining the bug species. We could do a Machado complement fixation test, and other serological testing to test for this disease. We could look for LD bodies or mastocytes that are going to appear in the heart muscle, but this usually happens post-mortem. So if somebody dies, we're going to look in their heart muscle and we're going to look for the mastocyte species. We could also do PCR testing to look for Trypanosoma cruzi. So it's known as Chagas disease or American trypanosomiasis. In chronic cases, an adult is going to be have no history of acute illness, but they're going to have an enlarged, weakened heart that may cause sudden death. Patients may experience a fever, weakness, enlarged spleen, liver, and lymph nodes. Acute infections happen common in children, and it results with an initial reaction at the bite site. And this is known. We could also see a periorbital edema if the patient's bit near the eye, so this is known as Romania sign. We could see cardiac ganglia destruction, megacolon, and rapid death with this infection. Distribution is primarily in Mexico, Central America, South America. Seropositivity rates range from 60 to 70% in Brazil and Bolivia. And again, Trypanosoma cruzi is something that we can see in North America. Many animals serve as reservoir hosts in the warmer southern states, but the Trimatoma species is going to be the main uh, fly that's going to transmit this disease. And usually, this fly feeds on warm-blooded hosts at night near the conjunctiva of the eye. Trypanosoma cruzi can cross placenta and cause the disease prenatally. Autoimmune reactions by antibodies that cross-react with EVI antibodies may play a role in heart, colon, and esophagus dilation. Donor blood must be tested using two different serological testing for Trypanosoma cruzi. And again, the major things you're going to want to take away from Trypanosoma cruzi is it's distributed by the Triatoma species fly, and it causes Chagas disease, and it has a unique C formation. So here is a picture of the amastigote where you could see it is in that C formation. We have a large terminal kinetoplast here. We're also going to note that we have our anterior flagellum here, a large central nucleus. But remember, this is the um, sorry, this is the amastigote. Whenever we're looking for Trypanosoma rhodiense or gambiense, we're looking for the trophomastigote. So you gotta note the differences in the diagnostic stage. Okay, so the next organisms that we're going to be talking about are the Leishmania species. We've got Leishmania tropica, Leishmania mexicana, Leishmania brasiliensis, and Leishmania donovani species complexes. This is also known as leishmaniasis. So Leishmania tropica is a cutaneous or old world leishmaniasis. Oriental boil, Baghdad, or Delhi boil. We have Leishmania brasiliensis is mucocutaneous or New World leishmaniasis. Leishmania dovani is a visceral leishmaniasis, Kala Azar, and Dum Dum fever. So it's important for you guys to note the differences in these different species, especially when it comes to the quizzes and the board of certification exam. So the incubation period for Leishmania tropica is several months or as short as 2 weeks. One or more ulcerated pustule lesions appear on the body and are self-healing. Lesions are usually moist and short-term in rural areas. Leishmania mexicana symptoms are similar to tropica, and there's also more subspecies. With Leishmania brasiliensis, we're gonna experience red, itchy, uh, indurated ulcer. Lesions may metastasize along with lymphatics and sequester. Lesions are usually self-healing, but it could cause disfigurement of the nose and ears later after chronic mucosal ulceration. Leishmania donovani, the incubation period is long with initial lesions. Short-term small papules are seen at the bite site. We can experience malaria-like spiking chills and fever. Double fever spikes can occur along with sweating, diarrhea, dysentery, weight loss, splenomegaly, and hepatomegaly. We could see hyperplasia of tissue organs occur along with progressive anemia. Death often occurs within 2 years if untreated. So Leishmania donovani is the one that we're going to worry about the most because 75 to 95% mortality rates. Leishmania tropica is found mostly in the Mediterranean area, southwestern Asia, central and northwestern Africa, Central America, and South America. Some cases have been seen in Texas. Leishmania brasiliensis occurs in Central America and South America. The highest concentration is in Brazil and the Andes. Disease is rural, so that's why it's named after Brazil because it's most often seen in Brazil. Leishmania donovani occurs primarily in young children in North Africa, East Africa, Asia, the Mediterranean, and South America. It's also seen in India and Bangladesh, but it's found in adults in India and Bangladesh. So cutaneous lesions may appear as ulcers, cauliflower-like masses, or nodules. Several animals can serve as reservoir hosts, so gerbils, rodents, monkeys, and dogs can be reservoir hosts. We could do skin tests to detect this organism, but the primary diagnostic phase is the amastogote. And these amastogotes are going to multiply in the tissue macrophages. So that's what we're going to see here. You see those amastogotes multiplying in a macrophage. That's mainly what we're going to be looking for. The other stage is the trophomastogote, but we're mostly going to be looking for the amastogote in the macrophages. The next class we're going to discuss is Kinetophragminophoria class. The phylum we're going to discuss is Celiophora. Balantidium coli is um, the largest parasitic protozoan that we're going to see in this class. This parasite is a tissue invader and produces intestinal lesions along the submucosa. There are also reports of vaginal infections with this organism, and this can be acquired through fecal contamination of the vaginal atrium. So whenever we look for Balantidium coli, ciliate form, we're going to look for trophozoites or cysts in feces or intestinal mucosa. Again, just like other parasites, we're going to want to collect 1 to 3 stool specimens to look for this organism, and we're going to prepare wet mounts of fresh or concentrated specimens. Excuse me, fresh specimens are always best with parasitic infections because it makes it a little bit easier to see these organisms. Disease names are balantidiasis or balantidial dysentery. Um, the disease may be asymptomatic, but when symptoms occur, they're usually abdominal discomfort with mild to chronic recurrent diarrhea or acute dysentery. A person who's healthy is less likely to develop an illness, and Balantidium coli is found worldwide. So if we look here at the Balantidium coli um, cyst stage, we're going to note that we have a macronucleus here, and that macronucleus is seen right there in the center. We could also see vacuoles present, and you see those vacuoles there. This organism is a little bit larger than most of the other parasites we've been looking at. The cyst stage can be 40 to 50 micrometers, and uh, the trophozoite stage is going to be 60 to 40 micrometers. Micrometers, yes. Okay, so the next parasites that we're going to discuss fall under the class of Sporozoa. Sporozoan parasites are obligate endoparasitic protozoa, and they have no apparent organelles or means of locomotion. This class includes some of the most important and widespread parasites of humans, including those that cause malaria and toxoplasmosis. So whenever we talk about the class Sporozoa, it's really important that we know that we're talking about malaria, babesia, and toxoplasmosis. All have a life cycle that includes both a sexual gametocyte, and those gametocytes produce sporogeny. Then we also have asexual phases, which is the schizogeny phases of reproduction. Most of these organisms have a two-host life cycle. So in order for these organisms to go through their full development, they're going to have to go through two different hosts. So we're gonna go into malarial parasites, and there are a bunch of different species of uh, parasites that can cause what is generally known as malaria. We have Plasmodium vivax. It's a common name of benign Tertarian malaria. We have Plasmodium falciparum, which is the malignant Tertarian malaria. We have Plasmodium malariae, which is your Quartan malaria. The Plasmodium malariae is the one that we most often will see in humans. And then we have Plasmodium ovaliae, which causes the ovaliae malaria. So the genus Plasmodium includes a sporozoon that causes human malaria. So the asexual cycle includes the schizogeny, which begins with an infected female Anopheles mosquito, which is the definitive host. Very important that you know that the definitive host for malaria is the Anopheles fly. So this Anopheles fly is going to bite a human, and it's going to inject its infective sporozoites, which enter our cutaneous blood vessels. These sporozoites are then going to travel to the blood and invade our liver cells. Inside of our liver cells, these organisms are going to become a cryptozoite, and these cryptozoites are going to reproduce intracellularly by asexual division, and then they're going to form a merozoite. This is a exoerythrocytic cycle and is completed within 1 to 2 weeks. Once the merozoites escape the liver and invade the circulating red blood cells, those merozoites entering the red blood cells can become trophozoites, and this is known as the ring form. And they generally do just look like a ring present inside of a red blood cell. So this ring form is then going to mature to the schizon stage within 36 to 72 hours. Each schizon is going to produce 6 to 24 new merozoites. And this depends on the species of malaria that the number of schizons that are gonna mature and the number of merozoites. So when a schizont matures, the red blood cell ruptures, releasing the merozoites. Those merozoites are then going to infect new red blood cells, and thus we got the disease spreading and causing an infection within the patient. So the cycle of a red blood cell invasion, schizogeny, and cell rupture continually repeats itself, producing symptoms. So this erythrocytic cycle, it happens in these steps. The merozoite is going to enter a red blood cell. It's then going to mature to a trophozoite, which is the ring form. That troph is going to produce schizons, and then those schizons are going to cause the red blood cell to rupture, and those new merozoites, which are produced by the schizons, are going to be released and penetrating new red blood cells. So each cycle induces a paroxysm. So this one, toxic material is released from the many ruptured red blood cells, and this paroxysm begins suddenly and is characterized by a 10 to 15 minute or longer shaking, chills, followed by a high fever lasting from 2 to 4 hours or longer. And the patient begins sweating profusely until the temperature returns to normal. So this paroxysm is primarily an allergic response to the malarial infection. So as you can tell, with all of these red blood cells being ruptured, essentially we're gonna see an anemia developing in our patients, and this anemia can eventually cause death. So later on in the infection, some of the merozoites are going to develop into microgametocytes. These are known as the male sex cells, and then they're also going to form into macrogametocytes. So micro is male, macro is female sex cells. So this sexual cycle or sporogeny begins with a female Anopheles mosquito ingesting these gametocytes as she takes in a blood meal from an infected person. These gametes unite in the stomach of the mosquito, forming a motile zygote, or basically, uh, it's like a baby. These. Um, so then this zygote is going to move through and encysted the mosquito stomach wall. And then after more maturation, an oocyst containing many infective sporozoites are going to be produced. And then these sporozoites are going to migrate to the mosquito salivary glands. And then whenever that mosquito bites another person, it's going to transmit the disease. Again, I want you to emphasize that this is going to be the Anopheles mosquito causing this disease. There are some drug-resistant Plasmodium species, and these resistant strains can rapidly evolve. There are 4 species, include the life cycle diagram. Plasmodium falciparum is the most deadly, and these parasites promote physiological changes in the red cell, which causes agglutination and lysis, and eventually renal failure. Some other Plasmodium species are less severe because they're unable to invade both young and old red cells. Like the Plasmodium falciparum is able to infect all cells. Plasmodium malariae can only invade older cells. Vivax and Ovaliae primarily infect reticulocytes or the immature red cells. So Plasmodium vivax is the most widely disseminated and most prevalent parasite causing malaria. So I take that back. I was wrong. It's not Plasmodium malariae. It's Plasmodium vivax. Um, there's a with Plasmodium vivax, there's a repeated exoerythrocytic development in the liver. So Plasmodium vivax can cause a relapse where the erythrocytic cycle starts again years after an initial infection. So you may, if the patient goes left untreated, there can be a relapse in this disease. I know that was a lot, especially since we were essentially just getting into it, but most of this information on these species can be found in your book on pages 100 through 103, and it gives you a way better breakdown than I ever could in these lectures about the different species of the organism. So generally, for a diagnosis, we're going to demonstrate and identify trophozoite, schizons, or gametocytes in a peripheral blood smear. Blood should be drawn immediately when the patient arrives at a hospital. So an initial test can be considered a stat request, and uh, we're gonna have to do another blood draw every 6 to 12 hours for the definitive test. We're going to want to do again both thick and thin smears for malaria. Negative morning and afternoon thick stain smears for 3 consecutive days during symptoms indicate an absence of infection. We could also do a rapid immunochromographic dipstick antigen detection test for malaria. Um, only one of these tests is used in the United States. We could also do fluorescent DNA and RNA stain films. We could do a PCR detection. But for us as laboratorians, especially in North Dakota, one of our first exposures to possibly somebody with malaria is going to be looking at the blood. So whenever we look at the blood, we're going to want to look at these different stages of the trophozoite. So here I have it the falciparum, the malariae, ovaliae, and vivax species. But I want you just to take a note of the ring forms here with malaria and the differences in how they look. Here we have Plasmodium vivax here, and it shows the different stages. So you could see down here we have the schizon stage, and it has 12 to 24 merozoites. So these small little infectious dots here are considered merozoites. We have gametocytes, which are eventually look like a round oval projection side of our red cell. So that's the gametocyte. Excuse me, the trophozoites again are the ringed forms inside of our blood. These Schuffner dots are indicative of Plasmodium species. So I want you to take a look at that Schuffner's dots that I expressed down here in the bottom. So again, it's really hard for you to look through a blood smear and not be able to notice these organisms inside of these inside of your patient's blood cells. So that's a quick run through of malaria. Again, I expect you to read up on these in your book as much as possible because it gives a really good breakdown of the organism, and I think you really should take some time to get familiar with malaria since it is one of the most widespread and most well-known parasitic infections. So Babesia is something that we're going to hear about in the United States a little bit more, especially here in the northern United States. So Babesia is spread by ticks, especially the Ioxides tick. Tick transmitted human infections have been reported. The trophozoites are going to look pear-shaped. So here, again, we're going to want to get whole blood or capillary blood to look for these parasites. The blood is going to be stained with Giemsa stain, which is preferred, but we could also stain with Wright stain. Distribution is worldwide. Um, we could do automated differential counting instruments can lead to diagnostic problems because these machines are not designed to detect bloodborne parasites such as malaria or babesia. So infections can be missed, especially if a patient's asymptomatic. So again, sometimes it's going to be missed by our machine, but if we do uh, if we do a differential, we should be able to see these organisms inside of the patient's blood. Patients may also get a concaminate infection, which means that a patient can get Lyme's disease or Ehrlichia infections along with their Babesia infection. And the species we're mainly going to talk about is Babesia microtili. So the Babesia, whenever we see them in a red blood cell or in a smear, we're going to see two different things. We're going to see a tetrad or a Maltese cross form, and that's what you see here with the arrow here. And we could also see ring forms. So you note those rings inside of your sample again. So in the northern hemisphere where we're located, we're going to want to consider the fact that has a patient been bitten by a tick recently? Has a patient been camping recently? Has the patient traveled to Africa or an area where malaria is prevalent? And that really helps us determine, okay, is this going to be malaria or is this going to be babesia? And again, Babesia has the Maltese cross formation here, and that's unique to it. So whenever you think malaria, when you think Babesia, you're going to want to think about the Ioxides tick, and then you're going to want to think of a tetrad, Maltese cross, and ring forms inside of the blood. Okay, I told you guys this was going to be a rather long lecture, and I could even talk a lot longer than I am about these organisms, but I'm just trying to get over a brief overview because whenever you guys do your chapter outlines and your homework and you review the objectives and you read your book, that's going to help supplement for this lecture. So the next three genera of sporozoa that we're going to talk about belong to the subclass Coccida. So I think I'm just going to go right into it because the main one that we're going to want to discuss is the very first one that we cover, and that's Toxoplasma gondii. And I'm sure some of you guys may have heard about this before, or some of you may have heard urban legends about pregnant women not being able to dump a litter box from cats, and that's because of the Toxoplasma gondii species. So let's just jump into them. But some of the parasites that fall into this class are Toxoplasma gondii, Sarcocystis species, Cyclosporo or Isospora belli, Cryptosporidium species, and Cyclosporo cadiensis. So Toxoplasma gondii, it's a sporozoan parasite that infects and undergoes schizogeny in all nucleated cells of almost all animals and birds. So again, the most common vector is going to be a domestic cat or other members of the feline species. and they have been cited as the only definitive host for this parasite. So in a cat, it's an intestinal parasite where both the schizogeny and sporogeny are occurring in the intestinal mucosa of the cat. The cat becomes infected after eating infective oocysts, and those oocysts are going to be viable for up to a year in moist soil. So eating tissues of infected small animals or by being infected transplacentally, these cats can get infected. So these oocysts are going to be shed in cat feces, and those become infected within several days for a variety of vertebrae, including humans. So whenever you hear about pregnant women avoiding dumping kitty litter, that's because of the Toxoplasma gondii organism. So humans can ingest the infected oocysts in contaminated food or drinking, or by accidental hand-to-mouth transmission from contaminated soil or cat litter. Toxoplasma divides mycotically into tissues of humans into tachyzoites, and these assume a crescent appearance when seen in tissue fluids. So that crescent appearance is mainly what we're going to be looking for a diagnostic phase for toxoplasmosis. The Radiozoites can also be seen and they remain viable for long periods. So I want you guys to take a look at Toxoplasma in your book. It's going to be found on page 105 and 106. With a Toxoplasma infection, we're going to want to do serological testing, and we could also do tissue biopsy for or impression smear stain with Giemsa stain, and we're going to see our um, this is where we're going to see our crescent moon shaped organism. We could also see the bradyzoites in periodic PAS testing, so periodic acid shift positive testing. So here you see this is the stage that we're going to look like for in patients. This is the tachyzoite, and it's the crescent-like appearance. This is what we're going to look for with Toxoplasma gondii. So let's move on. Sarcocystis species. So there's two species of Sarcocystis. It's formerly known as Isospora hominis in humans. They have a life cycle similar to that of Toxoplasma. Human dogs or cats can become definitive hosts if they eat undercooked intermediate hosts, which is the beef and pork tissue. And those beef and pork tissues are going to contain sarcocysts. Bradyzoites are released from the sarcocyst and invade intestinal cells in these definitive hosts. So humans, dogs, and cats are going to ingest sarcocysts from uh, beef or pork, and then it's going to undergo uh, reproduction inside of our bodies and cause infection. There's not much information in the book on Sarcocystis species, but it's just important to note that they're usually come in pairs. So you could see that here in the slide. The bradyoval oocyst contains two sporocysts, each of which contain four mature sporozoites. So we could just see that here in the picture. They're usually commonly seen in feces. The next organism we're going to talk about, when I learned about this organism, it was referred to as Isospora belli, but now it's Cystos Isospora belli. Um, there's only one pathogenic coccidian for which the human is the only definitive host. So schizogeny and sporogeny both happen inside the patient. It's going to be very mild infection. So here we're usually going to look for oocysts recoverable in zinc sulfate fluorination technique, and they stain very well with iodine. Again, most often we're not gonna come across this organism, but you could just take a look here at the egg and make sure that you guys draw it out. So Cryptosporidium species. Cryptosporidium is one that you guys should probably take really good note of because it's often tested on. There's two different species that we worry about with humans. We have Cryptosporidium parvum, which is found in both animals and humans. And then we have Cryptosporidium hominis, which is found only in humans. And you could find this information in your book on page 106. I'm just kind of brushing over it for you with these. So these parasites invade gastrointestinal mucosa surfaces in humans. Both trophozoites and schizons are attached to the host membranes We have 8 merozoites develop within the schizont, and on uh, maturation, human-to-human transmission occurs and nosocomial infections have been reported. The first human infection was reported in 1976. The symptom common to all reported cases is acute diarrhea, but the disease is usually self-limiting. So the patient's immune system usually takes care of this organism within 1 to 2 weeks. But oocysts can be shed intermittently for up to 60 days after diarrhea is ended. So we're going to want to do meticulous hand washing after an infection to further prevent this disease. But immunodeficient patients, so such as those with AIDS, or people receiving immunosuppression drugs, often develop chronic diarrhea after this infection. And this Cryptosporidium species, Cryptosporidium hominis, could actually be deadly for certain patients. And you can see it's a really small organism in this picture here. Next parasite we're going to discuss is Cyclospora cadiensis. It resembles the Cryptosporidium parasite. It patients are going to experience self-limiting diarrhea. There have been a few notable outbreaks in the United States since 1990. This typically was an outbreak occurred in Chicago where 21 staff members of a Chicago hospital were infected. The source of the outbreak was from drinking tap water that was contaminated with the organism from a rooftop reservoir. So that's why we would want to talk about this parasite. I'm not going to get into too much detail with this parasite, but you could look at page 108, and table 5-7 summarizes the diagnostic features of each one of these parasites that we just covered. So Sarcocystis, you could see the cyst stage there. It contains 4 sporozoites. Cyclospora species, you can see the immature cyst that contains immature sporoblasts. So these are the sporoblasts inside of the species. So next we're going to discuss microsporidia. So microsporidia have been recognized as tissue parasites in immunocompromised patients. I'm not going to go through these recognizable genre because it's not very often that we come across a microsporidia infection, and generally they're just going to be classified as microsporidium species. Um, you could cover this in your book. I think there might be 1 or 2 quiz questions about this species. Here we're going to want to do staining to look for these organisms. We could also do chromatographic and chemiluminescent staining. Here we're going to want to do tissue biopsies to recover these parasites. And you can see that in this picture here, the parasite is in this tissue biopsy that you can see there. But I don't want to get too far into detail with the microsporidium because they're not too generally discussed or common. And that's it. Um, if you go into your book on table 5-9, on page 110 and 111 and 112, it really gives a good breakdown of all of these parasites that we discussed today. It's going to talk about epidemiology, how the infection occurs, major manifestations of all of these diseases. And this table is going to be really useful for you whenever you're studying and prepping for the boards, when you're answering your case study questions at the end of this chapter for homework, or whenever you're doing the quiz. So really take a good look at that table. And again, it's on page 110 to 112. Now, I want you guys to go through and do the case studies. There's 1, 2, 3, 4, 5 case studies available for you in your book, and I want you to go through and answer the questions in that case study and attach it to your homework. Those of you who listen to the lecture will catch this, and those of you who haven't will get docked points. But I do want you to do the case studies because it generally, as laboratorians, everything when it comes to parasitology, microbiology, is going to come to us as a case study. So this is just good practice for you guys, and you should be able to tell what the parasites are just from taking a look at the pictures here. Alrighty, happy studying, guys, and sorry for such a long lecture.